We're going to talk today about solving right triangles. And what that means, because we've been talking about right triangles now for a while, I mean, we were doing trig yesterday, but solving right triangles means finding all three sides and all three angles. Basically means knowing every piece about that triangle, everything about it. So what I want to start with is a little construction. So take your protractor that you have and construct a right triangle with legs of 6 and 8. So you first have to make a right angle. So what I would do first is make a dot for a right angle, where you're going to put the right angle at, and then use that dot to, on your protractor, put that in the center of your protractor, and make a dot at 90 and a dot at 0. So if I bring my protractor over here and put that right on the middle of the dot, I can make a dot where 0 degrees is. I can make a dot exactly where 90 degrees is. And then you connect those two dots and you'll have a right angle. That's the most important part, is get your right angle first. Then you can make them the right size. So you're going to do the 8 going across. You'll do the 6 going up. Once you've got an angle, verify that it's 90. Put your protractor back on there and test that you have a 90-degree angle. If you look at the board, if you look at mine, you'll see that my bottom line goes right through 0 and my line going up goes right through 90. And then I want to make sure they're the right length. So grab the side of your protractor and measure the bottom one to be exactly 8. Get it as close as you can to 8. And then the top one, we're going to make 6. So measure it to exactly 6. Once you've got your 8 and your 6, connect them. Make a triangle. And label it for me. Put your 6 centimeters over here. And your 8 at the bottom. And then make sure you make a box for your right angle. So right now we have 3 pieces of our right triangle out of the 6. The right triangle has 3 sides and 3 angles, so it's got 6 pieces. We got 3 of them. We got 2 sides and we've got an angle. Now we have a protractor. So with our protractor and ruler part that's on the protractor, you could actually find the other 3 pieces. So first take your protractor, the measuring part, and measure the length of your hypotenuse. See what you get for the length of your hypotenuse. And if you drew your right angle correctly, if you made them exactly a 6 and exactly an 8, then your hypotenuse should be exactly 10. And you can see on here I got 10 centimeters. So it should be exactly 10 if you've got a 6 and an 8. That triangle has a special name. Do you remember what we called it? It's like a 3, 4, 5. We doubled all 3 sides though. Pythagorean triple, because they're all whole numbers and it's a right triangle. So it is a Pythagorean triple. Now let's use our protractor and find the measure of this bottom angle. So put your vertex of that angle right on the center of your protractor and measure that angle. You can see where mine is. It looks like it's 2 degrees above 35 on mine. It should be the same on yours, I think. Measure it and see if you got that. Why did I use the top numbers, the 35, and not the 150 or whatever? because the top numbers start at 0, right? The top number starts at 0. That's what you got to measure. So mine's a 37-degree angle. Plus, I know it's an acute angle. So I have to use those top numbers. That's going to give me an acute angle. So 37 degrees is what I got, and it's probably what yours is close to. It should be 37. Now, do we need the protractor to find this top angle?
No.
No, we could use our math, right? What do I know about all three angles in a triangle? 180. What about if one of them's already 90, what do the other two have to add up to? 90. So this one's got to be 53 degrees because 53 and 37 would add up to 90. So there's... All right, that would be using our protractor and the tools to solve. What if we didn't have a protractor? And all we had was a right angle with our 6 and our 8. And we didn't have the other three pieces. And we didn't have a protractor to measure them. How could we find the 10 without the protractor? A squared plus b squared equals c squared. We could have used Pythagorean theorem. That was one way to do it. Now the angles are another story. If you do not have either acute angle, then you're going to need to use your trig functions. But they're a little different. You remember on Monday, if you were here, I showed you the little buttons above, or the little words above the sine, cosine, and tangent. There's a little -1, and it means inverse. The inverse functions. To get an angle, you got to use an inverse function. Okay, so what I want to do is I want to focus our attention on this 37-degree angle right here. Okay, that 37-degree angle is where I want to focus our attention. Now, if I'm looking at this angle, the 6 is across from that. So what would I call that? The opposite side. And the 8 is below it or next to it. It's touching. That's adjacent side. Now, the hypotenuse up here is our 10. That's the biggest side. It's across from the right angle, so that's always going to be our hypotenuse. If I wanted to use the correct trig function, and I remember my SO, CA, and TOA, which trig function would I need to use? So, to get 37 degrees, but I don't know the 10. I only know the 6 and the 8. I got to use TOA. It's O and it's A, right? Those are the two that I had initially. So what I would do is I would take my tangent, but I don't want regular tangent because I'm not trying to find a side. What am I trying to find? The angle. So to get an angle, I need to use the little -1. I need to use the inverse tangent. Now, what's going to go on top of my fraction? What's the opposite side of the 37? 6. And on the bottom would be the adjacent side, which is 8. So the tangent -1 of 6 over 8. Now we're going to actually get to see how close our protractor is. We're going to see if we drew our triangle correctly because this is going to give us the exact answer. But I'm going to show you on the calculator on the computer. So I'm going to put in the inverse tangent. Now to do that, I'm going to put in 6 divided by 8 first. In this calculator, I got to divide 6 divided by 8 and get a 0.75. Okay. Now I can put in my inverse. So I can hit the inverse button. Now do you see how the sine -1, cosine -1, tangent -1 popped up on there? I'm going to hit the tan -1, 36.9 degrees. How close were we when we measured it with our protractor? Pretty close because we got 37. It actually does round to 37 if you're rounding it to the nearest degree. So we did a great job doing our 6 and our 8 and our 90-degree angle if you got this to be a 37-degree angle. Because the trig does give us that it's 36.9 degrees, which would round to 37. So that is 36.9 degrees. So you can see how we could, without a protractor, still find the measure of the angles as long as you have a right triangle and you know your trig functions. If you know your SO and your CA and your TOA and you know which one to use, I would get the right numbers. Now, if I use cosine -1 of 6 over 8, not going to give me the right angle. It's not going to give me 36.9. I've got to use tangent because it's opposite and it's adjacent. So it's got to be the tangent button. Okay, moving on here. What happens when we are given all three sides and no angles? We're given all three sides and no angles. You must use the inverse trig functions to find an angle. If you don't have any sides, if you don't have any angles at all, you've got to use the inverse trig functions to find an angle. Now, the inverse trig functions are the little negative ones. Okay, that's what you're going to use, the little negative ones. So let's look at a couple of them. Let's do a couple of practice ones. Here's 3 of them right here that we're going to practice on. You've got sine -1 means inverse sine, 6 over 11. You've got inverse cosine of 3 over 7. You've got inverse tangent of 12 over 7. There's 3 separate triangles there. They're not all from the same triangle. If I've got this sine of 6 over 11, what 2 sides of the triangle do I have? Opposite and hypotenuse. So in your calculator, if you were to do 6 divided by 11, and then hit the inverse button and hit the sine button, you would get 33.05, which would round to 33.1 degrees. So this would be a degree angle, 33.1 degrees. You notice that when we use the -1, you're getting degrees. You're getting an angle. So I don't know if you want to write that down there, but inverse functions, inverse trig functions, give you angles. Not sides. They give you angles. Inverse trig functions give you angles. So if I do the same thing for cosine, and you can do this ahead of me and see if you get them right. Plug in the 3/7, hit the inverse cosine, see what you get. Try your calculator, see how your calculator actually works, because you might be able to put in the inverse cosine first and then hit 3 over 7. This depends on what calculator you have. This one I have to do 3 divided by 7 and then hit the inverse cosine. 64.6 degrees is what we get there. 64.6 degrees for that second one. And then the inverse tangent of 12 over 7. So I have to do 12 divided by 7, which is more than 1. That's the only one that can be is tangent. And then I'm going to hit the inverse tangent. 59.7 degrees. So 59.7 degrees. That's how you get angles, is by using the little -1 on your calculators. The little inverse button. Hit the inverse button. On a regular calculator like this, it's going to say second on it. That's a different color, blue, on this kind of calculator. On your phone, it's just an inverse button, I believe. So you just hit the inverse button and you'll get the -1s. That's going to give you the angles. Inverses give you angles. Regular trig functions give you sides. All right, let's apply this and see how it actually works. Okay, we're going to start with a coordinate geometry problem. This is a good problem, and you're going to want to know this problem because it's going to be on Monday's quiz. Okay, I would study this one. I'd put a star next to it, whatever you need to do to do it, because this combines your Algebra 1 and your geometry together. Because back in Algebra 1, you learned how to graph y equals 2x minus 4. Where do you start to graph that when you graph that problem? On what axis? Y-axis. So make a dot right down here at -4 on the y-axis. Make yourself a dot right down here, -4 on the y-axis. Now what do I do to get to my next point? Okay, my slope is 2, which is like a 2 over 1. Tells me to rise 2 and to run 1, right? So from that -4, I'm going to go up 2 and over 1. I'm going to go up 2 again and over 1. Maybe do it 3 times and then connect them. When you connect them, that's the line that you get right there. That's the line y equals 2x minus 4. Now the question is actually asking us to find the angle that that line makes with the x-axis. So as you draw that line through the x-axis, the angle x is what we're looking for. The angle that it makes with the x-axis. Well, the only way that I could actually figure that out is if I draw in a right triangle. Because if I want to get an angle, I got to use trig. So I got to make a right triangle and try to solve for x. So I drew a triangle. I drew it bigger than I had to. I could have actually made a small little triangle in here, but I thought it'd be easier to make a bigger one so you could actually count a little easier. Now on this right triangle, how long is little a? 2 units. You can count. 1, 2 units. So little a is 2. How long is little b? That's 4 units. Okay, so we know we have a 2 and we have a 4. What are those sides called when you compare them to your angle x right here? 4 is the opposite. 2 is the adjacent. The hypotenuse we don't have, and we don't need it. We don't need the hypotenuse. We don't have the hypotenuse. So what trig function is going to help me solve for x? TOA. I got to use OA. I got to use TOA. So what I'm going to put over here is tan, but I need an angle. So I need to put what next to the tan? A little -1. That tells me it's an inverse. And then what goes on top? 4 divided by 2. Would it have been wrong in the calculator if I put inverse tan and then I put 2 over 1? Would that give me the same answer? That will give me the same answer. What would have happened if I put tan -1 and I just put a 2 in there? You would get the same answer. You could try any of those in there and they'll give you the same answer. All 3 times you get the same answer. So I'm gonna show you on the calculator here. It is the same ratio. 2 over 1, 4 over 2, and 2 are all the same. So I need to go 2 inverse tangent, and you're going to get a 63.4 degree angle. If I did 4 divided by 2, that's going to give me the 2, and then I'm going to do inverse tangent, and it's still going to give me the same thing, 63.4 degrees. So no matter how you put that in, you're going to get 63.4 degree angle. That's what angle it was with the x-axis. So this x is a 63.4 degree angle. So that's a good problem that you're going to want to know because it combines the geometry and the algebra 1. So I would definitely take a look at that problem again. Know how to graph a line, know how to find that angle, because you're probably going to see one of those on Monday. 63.4 degrees. All right, let's look at the next problem. It's going to ask us to solve a right triangle. These notes will all be online, so if you're missing any piece of it, we can go back and get those at any time. They'll always be there for you. Okay, solving a right triangle. It does tell you what it means. Find all 3 sides and all 3 angles. Now, what is it giving us so far in the problem? We have 2 angles, and we have a side. What side do I have? I have hypotenuse, so I could even put HYP down there just because I know it's hypotenuse. Now, let's see. What would be the easiest thing to find first? You're right, the other angle, because how would I solve for angle G? What's the quickest way to solve for angle G? I would just do 90 minus 25, yeah. And that's going to give me 65 degrees. So angle G then we just found out was 65 degrees. That's the quickest way. Now, what if you didn't know that these two small ones add up to 90? What would you have to do then? You'd have to add these two together and then subtract that from 180 to get the 65. Either way works. But these two do have to add up to 90 because one of them is already 90. 90 plus 90 will give you the 180. So that one's the easy one. If they give you one angle, to get the second angle is easy because you just subtract it from 90. Now I want to look, I'm going to stay focused on this angle right here. Okay, now I don't have to. I could go to the other angle if I feel like it. I have both angles. It doesn't matter. The only reason I'm focusing on that one is because that's what they gave me in the problem. I could focus on the other one if I wanted to. And I need to solve for these other two sides. So I'm going to call this one X, and I'm going to call this one Y. I need to solve for both of those, and I'm going to use the 25-degree angle to do it. So which side is the X compared to the 25-degree angle? That's your adjacent side. That's the leg that touches the 25-degree angle, so it's adjacent. And the Y represents the opposite. It's the leg that doesn't touch the 25-degree angle, so it's the opposite side. So if I'm trying to get X first, I've got adjacent for X, and I've got hypotenuse is 13. I can't use the opposite and adjacent right now because I don't have either of those two. I got to use the hypotenuse because I have that one. So I need the adjacent and I need the hypotenuse. AH. SOHCAHTOA. It's got to be the CAH, C-A-H, right? So let me write it up here again just in case. SOHCAHTOA. And if you notice, the C-A-H, adjacent hypotenuse. So I'm going to go up here and I'm going to put cosine of 25 degrees. Do I need the -1 this time? No, I'm not trying to find an angle this time. I only use the -1 if I want an angle. So I'm going to put cosine 25 equals, and my fraction is going to be X over 13. Because my opposite side is X. Adjacent side, sorry. My adjacent side is X, and my hypotenuse is 13. Now, how do we solve that problem? You have lots of different ways. You can put a 1 under this and multiply your diagonals. You could just simply multiply both sides by 13. Right? That'll get rid of the 13. So let's do that. Multiply both sides by 13. That's going to cancel out the 13s. So these are gone. And then you're going to get 13 times the cosine of 25. So in your calculator, let's see. 13, oops, got two of them there now. Cosine of 25. So 25 cosine, and then we're going to times it by 13. So in this calculator, I got to put in cosine of 25 first. Times it by 13, and I get 11.8. So this answer, 11.8. So that's going to be this top side up here, 11.8. Now, what do I need if I want to solve for y now? How do I get y? It's opposite. Do I want to use the 11.8 or do I want to use the 13? 13, because it's a whole number. It's a lot better to use a whole number. So I need opposite and hypotenuse, OH. OH has got to be SOH. So I'm going to do sine of 25 equals, and this time it's going to be the y over the 13. So that'll be the fraction I'll use for this one, y over 13. What am I going to do on both sides again? Just multiply by 13 on both sides. And then your calculator is going to give you 13 times the cosine or sine of 25. I need to put in 25 and then hit the sign. And then that's going to be 13 times sine of 25, and you hit equals. 5.5 when you round it off. So when you round that off, it equals 5.5. Now check and make sure your triangle makes sense. Where's my smallest angle? It's across from the smallest side. My biggest angle, 90, across from the biggest side. 13 is biggest, right? Good, so make sure it makes sense after you're done. But now we have all three sides and we have all three angles. Okay, look at it, the first example. That's the main example we want to look at. They gave us two sides. We don't get any angles. We got a 90-degree angle, and that's it. So what should I look for first? I could look for the third side first, or I could find an angle first. What do you think? Do the side? Well, you've got A, and you've got B, and you need C. What could we do? A squared plus B squared equals C squared. If you want to, those are really small numbers. That's what I would do. If they were big decimal numbers, I wouldn't do that. I would use trig because it's easier on the calculator. But if those are just 2 and 3 like they are, I would just do A squared. So 2 squared plus 3 squared equals C squared. Now what is 2 squared? 4, and what is 3 squared? So you're going to get 13 equals C squared. And you're going to square root both sides, right? So we would simply hit the square root of both sides. So square root of 13, square root of C squared. You're going to get, let's see, 13 square root is 3.6. So your side here is 3.6. Now we need to get my two angles, and I'm going to focus on angle A first. Okay, that's the angle I'm looking for. And I'm going to use whole numbers. I don't like decimals if I don't have to. So I'm going to focus on the two whole numbers. What sides are those compared to my angle that I circled? What's the 3? Opposite. What's the 2? Adjacent. Why is not the hypotenuse there? Hypotenuse is a 3.6, right? It's across in the right angle. So if I want to find angle A and I want to use whole numbers, then which trig function do I need? TOA, OA, right? I need the OA. So for letter A, I'm going to put inverse tan. I want inverse because I need the angle. Inverse tan. And then I want to put one on top and one on the bottom. What's the opposite? 3. I got to put 3 on top. 2 on the bottom. Adjacent goes on the bottom. It's always OA. OA. Opposite adjacent. So when you put that into your calculator, I got to do 3 divided by 2 first in this calculator. Gives me 1.5. Then I hit the inverse and I hit tangent. 56.3 degrees is what I get there. So 56.3 degrees. 56.3 degrees right there. Now, how do I get angle B? Fastest way. How do I get angle B? Do I use inverse trig again? I could. I could do inverse tan of 2 over 3. Or I could say simply take 90 minus the 56.3 and I'll have my other angle. So you just put in 90 minus the 56.3 and you'll get 33.7. So 33.7 is your angle B. So that's how you solve it when they give you two sides. Find the third side and then find the two angles. Now let's go down here at the bottom one. This is a little easier one because they already gave us an angle. So 26 degrees. Can I move that one up? Are you guys good there? Just want to move it up so you can see it a little bit better. Yep. You do not have to end the parentheses. You have to start the parentheses. Now, I would end it because I'm like that. I just like to see it ended. I don't like to see it open. It's the math teacher in math. I want to see the parentheses fully complete. But yeah, you don't have to end it, I've noticed. All right, so on this one right here, I would look for angle D first. How do I get angle D? 90 minus 26. 90 minus 26. You have angle D equals 64 degrees, right? So there's your angle D. Let's plug that in here so we have it, 64 degrees. That was the easy one. That's the first piece done for us. We need the two legs. We need X and we need Y down here. So again, I would circle the 26-degree angle right here, because that's the angle they gave me. Now I could use 64, so I'll get the same answers. But they gave me 26, so I'm going to use 26. And the side that I'm looking for is opposite. It's the opposite of 26. The side they gave me in the problem is the hypotenuse. So what do I need to solve for X with the O and the H? Got to use sine. So my DF is this one right here. I got to do sine of the 26 degrees equals the X over the 4.5. There's your fraction, and to solve that, what would I do? It's nice when the number's on the bottom, because then you're just going to multiply it by that number on both sides. So you're going to multiply both sides by the 4.5. And those 4.5s on this side will cancel out. So you're going to get equals, let's see, 4.5 times the sine of 26. So let's put in 4.5 times, then I got to hit 26 first, and then hit the sine. And then hit equals, and it's going to be 1.97, which is going to actually round up, if I did it to the nearest tenth, would be 2.0. So if I did this to the nearest tenth, this is going to be a 2.0 here. Now, how would I solve for the FE, this y at the bottom here? I need to use the adjacent side, and I need to use the hypotenuse because that's what they gave me in the problem. I don't have to use hypotenuse. I could use opposite because I found it. But I might as well use hypotenuse because that's what they gave me. So I'm going to use cosine of 26. Cosine represents the adjacent side y over the hypotenuse 4.5. So y over 4.5. And so we're going to multiply both sides by the 4.5 again. So that those will cancel out. And then in the calculator, you're going to do 4.5 times 26. This time you're going to hit cosine. And that's going to be 4.5 times the cosine of 26. You hit equals. 4.04 is just going to round to 4.0. So this one came out to be 2.0. This one down here came out to equal 4.0. If you're rounding it to the nearest tenth. The reason you should actually put 4.0 and not just 4 is because it's not exactly 4.4. It's actually 4.0 something, something, something. So you should have the 4.0 there. This last one right here is a pretty quick one. We need to find an A. I'm going to use angle X first. So take a look at this angle right here. The side they gave me is the adjacent, and they also gave me the hypotenuse. Which trig function has adjacent hypotenuse? Cosine. So I'm going to do cosine, but I need to do what to the cosine? I need a -1 because I'm looking for the angle X. So I got to use a little -1. And it's going to be the adjacent side over the hypotenuse. So that's going to be in the calculator just like that. I need to take the calculator I need to put 8 divided by 9.2. That gives me my decimal, and then put the inverse, and I need cosine. So it's a 29.6 degree angle if you round that off. So this angle equals 29.6. Yes?
When you put the quantity, do you only put them all when you do the inverse?
Yes, you have to do that for the inverse.
Okay.
But it does it for the other one automatically. But yeah, you need it for the inverse because you got to divide these two. Now to get y, I'm just going to take 90 minus 29.6 to get my other angle. And you're going to get 60.4. So that's 60.4 degrees. And so those are my two angles. To get this last side right here, I'm going to say that's x, little x, and I'm going to put, for angle x, I'm going to put 29.6 degrees in there. Now this represents my opposite side of that, oops, and the adjacent side is the 8. So opposite, adjacent, I'm going to use tangent here. I think tangent would be faster. I could use Pythagorean theorem. It would be okay. I just think tangent of 29.6 might be a faster way to do this. And it would equal the x over 8. X over 8. And so you would just multiply both sides by 8. Trying to hurry here. Multiply both sides by 8. And you will get, let's see what the calculator says to us, 8 times 29.6 tangent, and then equals. And you get 4.5 when you round it off. So this equals 4.5 for your last side. And don't forget about your school net tonight.